This is 14.1 Part 2. In this lesson, we will verify identities. So here is an identity, and we will use the basic trigonometric identities to verify this identity. To verify an identity, you have to work on one side of the equation only until that side equals the side that you have not changed. So we're going to work on the left side and see if we can make this equal tangent theta. So first thing I notice is we have a secant theta, and I know one of the basic identities is that secant theta equals 1 over cosine theta. So if I multiply these together, I get sine theta over cosine theta. And this is the tangent identity. Sine theta over cosine theta equals tangent theta. So we have just verified that the left side equals tangent theta, which is the right side. So that's verified. So now what about the domain of validity? Well, we know that the domain to the sine function is all real numbers. We know that the tangent and the secant both have asymptotes, and the asymptotes occur at odd multiples of pi halves. And it's actually the same for both of these, odd multiples of pi halves. So the domain of validity then is all real numbers except odd multiples of pi halves. Okay, here's another one. We want to verify this identity, so we're going to work on the left side and see if we can make it equal tangent theta again. So I know that the cotangent of theta is equal to cosine theta over sine theta, and 1 divided by cosine theta over sine theta would be 1 times the reciprocal, sine theta over cosine theta. And 1 times sine theta cosine theta is just sine theta cosine theta. So we know that the tangent identity says that the tangent is equal to sine theta over cosine theta. So we have just verified that the two sides of this equation are equal. Okay, what about the domain of validity? We know the domain to the tangent function is all real numbers except odd multiples of pi halves. And the cotangent function has a domain of all real numbers except multiples of pi. So if you put that together, basically you're excluding every multiple of pi halves because the even multiples of pi halves would be the multiples of pi. So domain of validity here is domain is all real numbers where theta cannot equal any multiple of pi halves. Okay, here's another identity that we want to verify. Again, we're going to work on the left side only. And the first thing I'm going to do is separate the fractions. So I have cosecant theta times 1 over secant theta. And one of my basic identities is that the cosecant of theta equals 1 over sine theta, and 1 over secant theta equals cosine theta. If I multiply these back together, I get cosine theta over sine theta, which I know equals cotangent theta, because that's the cotangent identity. So we have verified the identity. So now the domain of validity. Okay, for the domain of validity then, the cosecant of theta is not defined for multiples of pi. The secant of theta is not defined for odd multiples of pi halves, and the cotangent is not defined for multiples of pi. So if you put that together, again, the domain of validity would be all real numbers except multiples of pi halves. Odd multiples here, even multiples here. Okay, this will be the next video.